feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Kahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Morty the Rabbit, and more. Super Statistics Bros.
What is up, everyone? Good to see you in the chat. Adam, good to see you. Wesley and Thomas and Skylar and Gush and Gavin and Jesse and Knox. We're going to send an announcement here getting everyone started. Ava, good to see you there. So you can check your points right now. Megan, good to see you there. Check points. I'm sending a quick announcement. So make sure it's the right link. There we go. You can hear me in the background talking to myself because I'm always talking to myself. No one's liked the video. Like the video if you want right now. Go ahead and like the video. I'm going to switch over right here. But is everyone having a good day? What's up, Adam? Good to see you there. You're welcome for the review. Now, if you didn't check it out, well, let's give the announcements here in a moment. I was in a meeting just a second ago. Not literally, but about. Shouts to my meeting people if you're watching this. What's up? Sometimes I'm worried. I'm like, am I still on the Zoom call? No, I don't think I am. But how's everyone doing? Are you prepared for the final? I know we have a lot of time. The final is, 1 week from today? Tiny Brian, of course you can. He'll appear towards the end. He usually announces the winners of the Kahoot. So let me announce this right here. But ask questions about the exam right now. We'll just do feeling good. I like that, Logan. Feeling good. Nope. Well, we're going to get prepared right here. So let me open up the thing and let's just take general questions about the exam right now. So let's put into here. It is currently, we are at the 2:33 and general or questions about the exam. What questions do you have about everything from this unit? That's right, Megan, don't worry. There's a lot of time. This is better today than the night before, right? So if you're worried about the exam, let's talk about some advice right here. I'm going to bring this video over. We are sending off the announcements throughout the world to everyone. And we've already sent it to 201. Let's send it to 207. So here's what I would suggest. I'm going to send a quick announcement, then we're going to go check out the main screen here. So Kahoot starting, even though we're not starting right now. If you had to study anything, what would you deem the most important? Good question. So let's go look at what we did earlier today. And let's go to the main screen here. Here we go. Okay, we're over here on the main screen. We're going to talk about what to study. If you go to live right here, you see I was doing a review for the final earlier today. I think this is an excellent review. It's in different parts. It's a 3-hour review, and I do like 25, 30 minutes on each section. So it doesn't take like a long time to go through a section right here. You see the formula sheet. Oh, you see I'm talking to myself again. So I go through the full formula sheet, explain everything on the formula sheet. Then we talk about confidence intervals, the margin of error, all that good stuff. Next, we get into the errors, type 1, type 2 error, talk about that, take a break, take a walk around campus a little bit. We talk about hypothesis testing, statistical hypothesis testing, talk about the conditions for confidence intervals right there, or every sort of condition. But these videos right here are excellent. And also, I do want to point out, and I've been trying to point this out to every time we talk about this, there are a lot of videos. There's picture in picture for you right there. You can see right here, if you go to the playlist, you have access to a lot of these also. If you type in exam 3 right here, you see exam 3 speed runs. So these are some of my favorite things for you to study. I've made these videos right here that go over the material. You could go right to the testing if you want. No, this is a 31-minute video, not too long. You can email questions. Of course you can, yeah. So here's the speedruns playlist, or we need to change over to the chat. So I don't know why I said that way. Sometimes I think I'm on a radio call. Like, welcome to Stat 201. We are here to teach statistics. So here we go. Let's drop it in the chat, top chat, and here we are. So speed runs. You will not need to know the critical values. Good question right there. We will tell you those. There's the speedruns videos. Let me make it a little bit bigger. So many points. I know, right, Grace? Tons of points. So drop those questions if you have them, not about the exam material, but the Yeshiva Verity calculus is sort of weird to us. It's basically, I don't know if I can pull it up on this computer because I can't straight go through it. But the best thing to know, because a lot of people are very, I do agree, the calculator is not the best. The most complex thing you will do, and it's a lot like this calculator right here, is the square root is on the far side of it. It doesn't have the full thing on it. The most complex thing you'll need to do is square root. And if you feel like you were counted wrong on the test, you will get to see your answers. If it's a rounding issue, you will get the points back. Did everyone hear that? You can always just contact us and say, hey, Brian, I put in 6.57 and the answer was 6.58. I think I'll give you the points for that. So if you're really worried about rounding, and remember on the test, you have to use the Jujuva Verde calculator and there's no parentheses. So I would solve things in part. Here's how I would solve. Let me open up a Word document and then we'll start doing the Kahoot here soon. But we'll show how I would solve something using the calculator. So the most complex things you will have. What if I get you? We'll probably count that. It depends. I'll have to see what you have. So the most complex things you'll have to solve for. I was using the calculator earlier and you have a very lockdown. The biggest thing is just punch in the numbers and then solve. Like here is an example problem. You ready? So we might have that we're solving for a confidence interval for the mean. And the problems are not as big as Pearson problems. The problems are going to be things like, what is the margin of error? Well, here's a classic problem. You ready? Here is a classic problem we've used. And the exam looks like the Canvas contents. That's how it looks. Good question right there. So let's say we create an interval that goes from 6.7, oh, 5.7. 6.7 to, let's say, 14.3. What is the margin of error of this interval? This is a classic type of question to the degree of which we ask certain calculations on the test. Who can tell me the margin of error of this interval? And I'm going to change this. That's easier now. Who can tell me the margin of error of this interval? So don't worry if you did the previous one. Just take half off of it. So can you figure out the margin of error of this interval? Skylar, that is correct. Skylar solved it before I made the change. Skylar does have the right answer, and so does Carson right there. That is the right answer for the interval I'm showing right here. And good work. So, well, we'll show the one right here. I wanted to make it really easy. So, and everyone's getting it so quick. Well, Glamorous, let me show how to get this. What is the margin of error of an interval? The margin of error of an interval is always what the length of an interval. The margin of error is always, what's our memorization for it? The margin of error is always what the length of an interval, half the length. So the length of the interval is this. The interval goes from 6.7 to 14.3. The margin of error, which we're looking for, is half of the length. So what we want to do is the formula upper minus lower, which this is the upper and this is the lower, divided by 2, because it's half the length. This is a margin of error. This is the full length. Does that make sense conceptually to people? That's not the center. It's the margin of error. I was thinking, because I was like, oh, and the upper plus the lower divided by 2 is the center of the interval. So that would actually be the center right there. So all these things right here. And so you'd plug into the calculator. You would just do, you bring it over here, and you would say upper minus lower, and then you would divide by 2. There you go. And that will get you the answer. We're not doing very complex things. I guess a slightly more complex one you might have to do. Let's do a slightly more complex one. A slightly more complex one could be something like this. What is the standard error for the confidence interval? We took a sample of 100 students and found a mean of 8 with a standard deviation of 2. So what is the standard error? So who knows what the standard error is of this? I sometimes have easy calculations like this because you barely need the calculator for this. And I'll show how I would do it on the calculator. What is the standard error of this interval? Not quite. Good guess, Skylar. Good guess. So what you want to do is you want to go to the formula sheet here. And you can use the formula sheet, true. And Ava's got the right answer. Nice job, Ava, right there. So we're going to show the formula sheet and show what we're doing. Great job, Joshua, right there. So, and Thomas too. Great work. So here's the formula sheet. We're pulling it up in the background here. And we go right here. And we go to exam 3 formula sheet. And notice we are doing a confidence interval for the mean, and the standard error is the following formula, S over square root of n. So because we're doing a confidence interval for the mean, so the standard error is S over the square root of n. So you go back here, and you write S over square root of n, where S is going to be the standard deviation, and n is going to be the sample size. And if you're solving this in the calculators, this is the standard error of y bar. And so S is 2 over square root of 100. What I would do right here in the calculator is I would do 100 and then hit the square root button and get it. You could write this down if you want. You can write down the answer that you got right there. Just lets us see your work. And then you're doing 2 divided by 100. So 2 divided by 10. And that is equal to 0.2. So does that make sense right there? So I would solve out what's under the radical first. So I would solve out square root of 100, and then you've solved that. And this is the mean right here. The other one, which we're not doing right here, but good question / answer, is p hat times q hat over n square root. And this is when you're dealing with proportions. So the biggest thing is just practicing. Watch some of the videos, go through, try writing your own practice problems. And a new feature, let me put this in the video right here, a new way to study, a new advanced way to study. Let's go to the video from today. So this is the video from today, and I want to show you a new thing I'm trying out and seeing if it works. We're going to go to the review for the final video, and then we're going to go down here. We're going to pause the video. We're going to go to the description and go to ask questions. And I'm going to say, go through the material in this video and make a 5-question quiz for me. So you can ask with Gemini right here, Google Gemini. It's going to use my video as its background. We saw some slight errors, but look right here. Answer in the chat, A, B, C, or D. When building a confidence interval for the population mean, which distribution should you use? Which distribution should you use if you have a sample size of 10 and the population standard deviation is unknown? That is a little, well, I see the right answer on here. They're going a little more complex, but the right answer should be obvious. Which one? What is it? I think people are getting it. I tried using it on the video and it didn't work for me. Does it? I don't know. Let me know people's success with this. This is like a newer feature. You might need to be in Chrome, but it is B. You are right. It's and what they're saying right here, the standard deviation is unknown. That's telling you have S instead of sigma. We don't cover the alternative because in theory, you don't ever really know the truth if you're making a confidence interval for the, I have my qualms with the other interval, and we don't teach it. In the context of statistical testing, what is the primary purpose of the success failure condition? What is it, A, B, C, or D? So when you do the success failure condition, what is it? It's actually a pretty good question. I'm actually shocked. It's actually a pretty good question. It is A. It's to determine that it's approximately normal. If you have at least 10 successes, at least 10 failures, helps with the normality. What is the relationship between the level of confidence moving from 95 to 99 and the width of the confidence interval? A, B, C, or D? Good to see you, Rowan. What do you think is the relationship right here? What is the relationship? Is it C? The interval becomes wider and decreasing precision. Wow, perfect. And look at that. We were covering that a lot in this video. It's using my transcript as what it learns from. If you are conducting a two-sided hypothesis test that does not equals test, and you know the p-value for one test, how is the two-sided p-value calculated? We will be reviewing this if people don't know how we got this. Well, good to see Grace right there. What do you think we do? If we know we're doing a two-sided and we know one of the one-sided, what do we do? A, B, C, or D? It is C. We multiply the smallest by 2. We'll go over that here in a little bit. But these are all pretty good questions so far. What are the 3 factors that influence statistical power? A, B, C, or D? A, B, C, or D? What are the 3 factors that influence statistical power? I think there's 2 to be tricked between, but it's what? What is the 3 factors that influence statistical power? It is B. Good work right there. It is B. It is sample size, effect size, and alpha level. There we go. And it'll even tell you got them right. I wish it was a clickable quiz, but it should say correct. You got all 5 out of 5. Give me 3 more questions on statistical tests. But has anyone tried this yet? What are your thoughts on this? I think it's pretty neat that you can do this and it uses it. It is clickable if you use the app. Oh wait, so Adam, have you confirmed that it's a clickable? It is clickable right here if you use the app. We'll do some more review, but this is the last for today. What is the primary difference between the 1 and the 2 sample T? It didn't do multiple choice, but Adam might be saying in the app it is clickable. What about the website? Which website? Which I don't know which website. But good stuff. The UT campus event had a Gemini booth that showed us a clickable quiz. Yes, and that's through Gemini. Yeah, I saw that, Adam. I was actually at that, and it was pretty neat. And I don't know why it's not. Oh, so you're saying real quick right here, and then we're gonna actually start the Kahoot. Adam, are you saying if you are in, but does then it use my video? Oh, you're saying like if you open the video, and you might have to show me that you can upload your notes and make a quiz from it too. Exactly. Yep. So Google Gemini can do that, and I guess you could take the transcripts from the videos and upload them. Or you might be able to say go to the video because I was trying to do that, and I think it actually worked. So pretty neat what you can do right here. The Google Gemini app right here. Maybe upload the video link in Gemini. Yep. And so it's pretty awesome. You can quiz yourself, and so far it's been pretty accurate. The 2 sample T, I'll answer these, then we'll start the Kahoot. Sample T looks at the difference in the mean of 2 groups. Look, it even gives you where I talk about it. When conducting a chi-square test of independence, how do you determine the null? The null uses the word independent between X and Y. Might get mad. That might not be enough details. In the context of statistical testing, what does it mean if you fail to predict null hypothesis? You did not find evidence for the alternative. Your p-value was above the alpha level you picked. So there we go. That's got it. Number 4, back on the previous one. Whoop, we're losing our spot right here, but we're going to do the Kahoot. If you conduct a 2-sided, we'll be showing that here. Well, let me show that one, and then we'll start the Kahoot. I keep saying we'll start, but did it like all 3 are correct? So let's show that. Here is how. This is the last thing, and then we're going to jump to the Kahoot. And check out the earlier stuff today because we go over some of this too. If you have, actually, you know what? We're going to show the test question on this. So if you go to review 3, a lot of people have been asking about this question. So Gavin, really good question right here. And we're going to go look at review 3 and then look at a question a lot of people are stuck on. Now, is there a video for every single question on the practice exam? Who knows? Yes or no in the chat. Is there a video? And let's put this in the notes right here. Where to get video help. So this is our last topic before the Kahoot. Where to get video help. To get video help, you can just go here to the playlist on the channel. And you will see if you type playlists right there and go to, I guess you go to exam 3. Well, that might not bring us there. Look at this. There's so many. Practice test 3 review. So if someone can't find it, we're going to drop this video in the chat right here. Practice exam can be found on that link right there. Click the link. It'll bring you right to it. So review videos right here. So they're also on that review page, but click that link dropped in the chat by Mewbot right there. Mew2 says review for the test 3 can be found here. And take a look at this question. This is the question we're about to talk about. And then I also show you visually a lot of the details on this. I show how these p-values are found visually speaking. So I try to walk you through how to solve these things and give you some advice. So a lot of people have been stuck on this one. We kind of updated the output to look less like jump. A lot of people have been stuck on this question on how to get the p-value. Okay, so let's talk about how to get the p-value. So what's the deal? As Jerry once said, what's the deal? What kind of test is this? That one right there in yellow. What kind of test is that? Who knows what kind of test that is in yellow? Correct, Jake, right there. Correct. Who knows the one in yellow? That is the what alternative? It's the greater than alternative. The one in green is the less than. So this is the less than. This is the greater than. And there's also the does not equals alternative. The does not equals alternative is greater than absolute value right there. So the way this looks is if you have a normal curve, you would plot where your test statistic lands. So your test statistic on any of these can be plotted, and we would plot it. I think it's because greater than is going to be a lot. It's going to land way over here. So this is where your t statistic landed. We won't go through and calculate the t, but that's where your t landed, which means the area greater than it is almost all the curve, as in this is 99.67% of the curve. How do you get the less than p-value? If you know this is 0.9967, we did this before the joke came out. How do you get the other one? How do you get the less than? The less than p-value would be obtained how? Well, Megan's on track for the one we're missing. Great answer, Megan, right there. And we would subtract. Perfect answer. Because these two have to add up to 1. They add up to 1. So you just do 1 minus. But then the does not equals means you take the area and reflect it on the other side, and Megan's giving the right answer. So now, think about this. Do you see this area here? It's this area, which is the same as that area over there. It's merely a reflection. So what would be the p-value for the does not equals test? Megan showed it right there. All you do is take this and take the point, oops, wrong color. You take the 0.0033 and put it on the other side. So it's basically times 2 of the smallest. So whatever the smallest one was, it's going to be times 2, so it's 0.0066. Does that make sense? So it's twice the smallest because you're reflecting on the other side. So that is how the p-values can be found right there. Just knowing the relationship between them, the less than, the greater than, add up to 1. And the does not equals is 2 times the smallest of the two p-values. So we don't ask you to use tables or stuff like that. And so greater than absolute value. I believe so. Kind of divide by 2, exactly. Well, then you don't know which one's the smallest unless you know which side you land on. If you land on the left side, the lower is smaller. If you land on the right side, the greater than is smaller. So you could take half of this and you would have one of the two p-values. It does depend though, because if you land on the other side of the curve, the greater than, because it could be that you landed up there and then you would reflect on the other side. You would reflect this down there. And then the greater than would be smaller. Anytime you land above the mean, the greater than would be smaller. Does that make sense right there, Jake? And good questions. I like it. So if you land up here, the greater than is smaller. If you land down here, the less than is smaller. But we landed on the very left side of the curve because only a fraction is left on the left side. So with that, it is time. Well, it's practice. Don't worry. I had someone say to me one time, it's the best compliment I've ever gotten. They said, one day they woke up and it all made sense. I wish that for all my students. How to get another. Oh, that's all right. Well, no worries. Jake, shouts to you right here. Hour and a half. It is recorded, so you can check it out later. And thank you everyone for being here. We're going to get that Kahoot going right here. If you can't stay the whole time, that's all right. It is recorded. So we are going to do the exam 3 Kahoot. I'm going to double check, make sure I have the right Kahoot. I think I do. I think I do. Let's see. Okay, this is looking good. I think I removed out. I have I did it questions, but I'll keep those in there. Let's go to host live. I like that, Adam, right there. Yeah, once you see it a few times, you start to realize it, and you're like, wait, I know what's going on. Okay, here we are. We have the Kahoot going. Let's start the Kahoot. We'll put here start a Kahoot in the notes. Where to get video help has already been there. We'll put a minute on the clock. And I'll start when we get to there. We want it all to make sense. Did someone text me? No, it's I'm supposed to be teaching. Is anyone getting all these fake calls right now being like, your loan is approved or we want to get you for your loan? Anyone else but me? I hope not, Chloe. Not really much. If you ever feel there's a problem, let us know. If you're like, hey, I think I entered maybe 1 decimal off, look over your answers, especially when they're released, and let us know. And thank you, Chloe, for asking that. I don't like long decimals. Think of this. What is the margin of error of an interval that goes from 80 to 100? What is the margin of error of an interval that goes from 80 to 100? That's crazy, right, Lily? What is the margin of error of an interval that goes from 80 to 100? What is it? Let me make this really big so people can click it. It's 10. Because it would be 90 plus or minus 10. And so if you know the margin of error is half the length of the interval, it's just 100 minus 80 is 20. And then that puts 90 in the center, plus or minus 10. There is a 90. Is it 90? I believe it's 90 minutes. I could double check. I'm always afraid to say, like Silva says it all. I always joke about, I don't joke, but I always talk about the one time I sent my students to a broom closet. Good times. The broom closet was across the hall from the actual test room, but I did send them to a broom closet. There were students standing next to it, and I'd be like, test is over there. Sorry about that. The calculator does not show you what operations you entered. You just have to be super careful. True. Check your work. I'd do it twice. And there's not a ton of really big kind of operations. I hope the last test isn't terrible. I don't think it's so bad. And thank you to everybody. I really appreciate everyone who's been very positive about understanding these changes. It's 90 minutes. And should see how many questions on here, right? We should see how many questions. 100 points, 90 minutes. Well, yeah, the professor. True, Penelope. Is there going to be a fault? No. Here's how a chi-squared question will look, and then we'll get started. Chi-squared questions often show you things like, and I think I have some in here. Here's how a chi-squared question would look. Find the expected cell count for yes. Find the expected cell count for yes. Find the expected cell count for yes. So who can do that right before we get started? I think I can get it. 2 times 2 is 4. Add the zeros. You get about 40,000. Divide by 3. Should be about 133.33, I think. Maybe? Yeah, there we go. Josh, we got it. Yeah. So it'll be row total times column total over grand total. Row total times column total over grand total. There we go. I think 4 over 3, but it's got a bunch of extra zeros, or like, because 4 over 3 is 1 and 1/3. A third is 3 repeating. So I love, this is my last thing. I know I say like last things. Well, so a student actually helped me. Think about this. What is what is 7% of 100? Well, you can actually flip it and do 100% of 7 is 7. What is 5% of 20? We can do 20% of 5, which is 1. So 20% of 5, because you cut it into 20th or 20%. So what is 20% of 5? It'd be 1. What is 5% of 20? It'd be 1. So it's interesting. You can flip it. Like, what is 9% of 80 is the same as 80% of 90, which might be easier. Yeah, that'd be easier. That's 7.2. Wow. So, 80% of 9 is 7.2. 9% of 80 is 7.2. You can do those tricks. So really neat. I like that. What does that do again? Oh, the question we just did was talking about what you'd have to solve, not a full chi-square, but just like the expected cell count. So if I'm calculating the chi-squared, you'd give me the values, right? Yeah, and we'll see some questions like that coming up here as we start the Kahoot. Yeah, we're not recording emails on this one. This is just a for fun Kahoot. Now, do remember, please email me if you win. $20 for first place, Amazon gift card. $20 second place, Amazon gift card. And $20 for third place, Amazon gift card. Please email me if you win as we start the Kahoot. Let's do this. Here we go. And we'll go over each question, so feel free to ask questions as you see them. We don't have socks, we have shirts. How will we test to see if there's a relationship between married students and their age? So we're seeing if there's differences between the married students and their ages. How would we test this? How would we test this? Now you have the one sample T. What's our mnemonic about Mr. T? If this is your first time watching any of our streams, what do we say about Mr. T? What do we say about Mr. T? He's mean if you're doing drugs. Exactly, Megan knows right there. Mr. T is mean. The one sample T is when you're analyzing one mean. The two sample T is when you're analyzing two means, the mean of one group versus the mean of the other, looking at the difference. Chi-squared has the condition count data, which requires what? When you have count data, Mr. T's the Grinch. He's a mean one, Mr. T, if you're doing drugs. So chi-squared has count data, which would require both variables be what? Would require both variables be what? Chi-squared requires both variables be what? Two categorical variables. Exactly. I'm going to blank the screen real quick. We'll take a picture of this. I already got a picture of that. There we go. So the chi-squared requires two categorical variables, and one proportion z would be one categorical variable. So it is the two sample t, and the two sample t specifically looks at the difference between two means. What graphic would you have for this question? The two sample t, and let's do it above and below. What graphic would you have for the two sample t? I think you're comparing two means. So what graphic would you have? Side-by-side box plots, true, exactly. Because you'd have married no and married yes, and you might look at the ages of the groups, and you would compare the two groups. For the one proportion z, you would actually just have a bar chart, because you would have the proportion of not married versus married students. This is a totally different question right there. But then above this, the chi-squared test, you would have, what is this called? Maybe if you look at, do people live on or off campus versus married, not married, it probably would look more like this if you have on and married yes versus married no. So this would probably be like, do you live on or off campus, where you'd see a strong relationship. People married are less likely to live on campus. So that is a mosaic plot, or mosaic plot as we like to say. And then the one sample t would just be one box plot. It would just be a singular box plot because there's no extra variable. This one right here is univariate. This is univariate also. And these are bivariate. So these are the bivariate ones because there's two variables. Do students live, are married students independent, is being married independent of living on or off campus? Is there a difference between the age of the married versus non-married? And when would you do a one sample t? You might just want to ask, is the average age of students older than some hypothesized value? In the past, the average college student was 20 years old. Is there evidence that the true age of a college student is, and we'll do the alternative, is greater than 20? Does that make sense? The null would be that the average age of a college student is 20, if that's the historic value. And then do we have evidence that the average age of a college student is older than 20? This one down here would be something like the null hypothesis would be that the proportion of not married students is equal to something like 40%. That's sure, why not? And the alternative might be the proportion of not married students is not equal to 40%. You could test whatever alternative you want. Researcher gets to pick it. And this one over here would be the null is that the true mean of non-married minus the true mean of married has no difference. The alternative, you can just say the true mean of not married is not equal to the true mean of married. And then I'll answer the last one up here. The null up here would be x is independent of y. And the alternative would be the x is associated. So x is associated with y. That says associated. I ran out of room. So one proportion z is it's a singular bar chart right there. The one proportion z is just a bar chart because you're asking, are students married? Does that make sense right there, Jake? That this is just, are students married? Yes, no. So it's just a bar chart. There's two levels to it. It wouldn't be two bar charts. It's just a bar chart with two levels. You could have more levels, but we usually look at like the proportion of married students or something like that. So you usually hone in on one of these and say, is the proportion of married students equal to 40%? And you would analyze that. The T over here looks at one quantitative variable like the average age of students and asks, is the average age of students equal to 20, the true average? So that has it. Good question/answers. This is a tools and techniques question. Let's do another. Electric Hummingbird in the lead. Here we go with the next question. How can we test the relationship between someone owning a pet and if they're married? Great review question. Who can name the condition in the chat that this one would pass? So who knows the condition that this would pass? It's splitting up? CC, that is right, Gavin. Good work. Everyone's saying CC, which is counted data. It's cat. Two categorical variables, count data. So when you have count data, that is the fourth condition for what test? Joshua, nice listening. I do mention that. Like, you remember when I said that? I like that. because QQ is regression. And you are right. It is the chi-squared test of independence. And so what would be the null? Who can write the null in words right here? What is the null hypothesis for this test? Owning a pet and being married. What is the null? This is our practice time right now. I'll ask you a lot of questions. Answer as many as you can. What is the null? And then you could use the Gemini on this video. What is the null for this test? So you have to write the null. If people are doing it, owning a pet is independent of being married. Exactly. Who likes this chapter because of that? Like, to write the null, you just put independent between the two things. X is independent of Y. Alternative, X is not independent of Y. Or you could say associated or relationship. I know Glamorous, right? It's really easy. And then it's a bunch of math. Like, it's very, very strict on the math. And then it follows the same rules of the p-value and everything. So let's do the leaderboard. I do too. Flawless enchilada. That's what it says in my mind. And classy nude and optimistic blackbird. Here we go. When doing a hypothesis test on the mean, which is the condition that must be met? So a hypothesis test on the mean uses which of these 4 conditions? I'm going to give a shout out to myself here in a second. But shout out Brian. And thank you, everyone. We have almost 50 students watching live way before. I'm going to give a shout out to myself. So we have a saying in our class, whenever we do conditions, we say condition 1, random, which is not on here. Condition 2, 10%. And then we pause. Should have put pause on the chart today. So here we go. I'm getting the video up. Get it paused them. Surely I show the screen. Trying to get it. So there we go. Got it. Pause. Put those pause in the chat. Love it. Ooh, a lot of people said success failure. So here is a chart to take a picture of, and I would highly suggest writing it down. Success failure is when we're working with what? So here is the chart. Success failure is when we're working with what? When do we have success failure? Success failure is used when what? So take a look at the chart right there. Success failure is used when what? Success failure is used when only a categorical variable, when testing proportions. When we do means, it goes random, 10%, then we pause, because it's always random, 10%, and then we pause, and then the nearly normal means that both distributions need to be mostly normal. We go into bigger details here. There's the 4 ways to check it. We don't go into huge details on the test, but it is the 4th. You notice how I have means colored right there and means colored, and then the 2 sample right there showing you 2 samples comparing the means, and the counted data right there with the coloring on the categorical. So I tried to color code this a little bit to help out and know the 4 conditions. There's not 4 conditions always. It's only when you get to the last 2 chapters that there's 2 extra conditions after we do the less than 10% of the population is sampled. So good work right there. The counted data or expected cell counts are for which test? Just say in the the chat real fast. Counted data and expected cell count are for which test? Well, the answer is on the screen. The counted data, it's for the chi-squared test of independence. Exactly. Chi-squared test of independence. Good work. Good practice on the conditions. Optimistic Blackbird in the lead being that flawless enchilada. Which condition do we need at least 5 of? And we'll practice this here in a moment to see if you can solve it really quickly. Let's go over some of the conditions. It's not the counted data or count data. Either or is fine. Rock knows. It doesn't matter. So count data means that it's counts as in like you have 2 groups. It has to be 2 categorical variables. So you can see I've highlighted it in green right there because you have to have a categorical Y and a categorical X. So that leads to 2 categorical variables, count data. Success failure is for proportions, and you need at least 10. No, you got this, Jack. Don't worry. That's all right. We got a saying here. Get it wrong in class. Who knows the rest of that saying? I'm going to let someone tell you in chat. We got a saying here. So success failure is going to be for proportions, and you need at least 10 successes and at least 10 failures. You get it wrong in class, get it right on the exam. Oh, no, don't get it wrong on the exam. Get it wrong in class, get it right on the test. Exactly. The only way you know you're wrong is that you say wrong things. You think anyone lived their life without getting things wrong? I'd love to meet that person. But you say wrong things to learn right things. So people who are afraid to be wrong, I hate to say it, that's a flaw in my opinion, because, and I probably have that flaw. I don't know. Been afraid to be wrong. Get over it. We move on. We're wrong. We acknowledge we're wrong, and then we learn what's right. So like a QB misses passes in practice, but boom. I like that analogy. You think that QB hasn't missed about 1 billion passes? They're practicing right there. How do you check for expected cell count? Perfect. So yeah. Are you part of this group, Lily? They gave me a free t-shirt. So I was like, free t-shirt? Cool. So expected cell count is going to be the formula row total times column total over grand total. We can take a look at that a little bit later. We'll check that out, Megan. So it's row total, that's RT, times column total over grand total equals expected cell count. This is given to you on the formula sheet. So with this, any group that gives me a nice t-shirt with anything positive on it, I'll probably wear it. So we go right here and we put 300, 200, and 400, 100. What is the expected cell count of McDonald's graduate students undergrad? We asked students if you would go to McDonald's or Burger King. And I'm going to solve in my head before you guys. You ready? Oh, wait, I can do it. I think I got it. Well, I'm going to put it behind me. Okay, there we go. Oh, you did it, Scholar. It was super quick. People are going to think I cheated off you right there. And then Megan's writing it right there. So you have to take the row total for the one you're calculating, row total times, and great job, Skylar. Shout outs. We're not doing MuBot points right now because I want to end the MuBot points. That way people don't get more points. Because I want them to be like, wait, I got 1 billion more points. Row total times column total over grand total. You basically circle the ones. Does this make sense right here, Jake? You circle the ones that cross over each other, and that points in on this cell. And that's the expected cell count for that cell, meaning you would expect there to be 240 graduate students who like McDonald's, just from the numbers. That's not what you observe, because you might see only 200 graduate students like McDonald's. Now, who can tell me UG, MD, UG, BK, what is the cell we really need to check right here? So remember, all these expected cell counts need to be greater than 5. What is the one we really need to check? Who can tell me the combo of the one that would be the best to check to see if we meet the condition for expected cell counts greater than 5? And here's a hint. The grand total never changes. And I think Megan's got it right there. It's going to be Burger King and then undergrad. And the reason is because those are the two smallest. Think, if the top of the equation is the smallest, that's going to lead to the smallest expected cell count from the smallest row total, the smallest column total, over the grand total. The grand total doesn't change, so it doesn't matter. It's kind of like if your youngest friend is 22 and you go out to the bars, everyone's old enough. So this is the smallest expected cell count. And we can take a look at it. Well, I think it's going to be, oh wait, I should be able to do it. Come on, brain. Let's just 40% of 100. So it's 40. Oh, there you go. That was easy. I think it's 40. Boom. There you go. So since this right here is bigger than 5, we pass. Does that make sense right there? So you can check each one individually, but you can also just check the smallest, because if the smallest is greater than 5, well, then they're all bigger than the smallest. It is all expected cell counts. Not 5%, though. It is literally 5. So what does this mean? This 40 means what? If we were to go out and look at the data, what does it mean? What does expected mean? Think of what we're saying when we say expected. Remember, this is undergrad Burger King. It's what people like in their classification as a student. So what does 40 expected mean? It's not percent, though. What does it mean? I'll let someone try to answer, and then I'll tell you. And just think, what does it mean 40 expected? Out of the 500 students we talked to, we would expect... Exactly, we'd expect 40 undergraduates to like Burger King. Does that make sense? So that's what we expect. It's not what we saw. It's what we expect, because the test then looks at the difference between the observed minus expected squared over expected. The test then looks at this different. You're expecting the amount of undergrads who like Burger King to be 40 exactly. That's what we expect. That's how many we expect to see. And then we look at the difference, and it's called the chi-squared, and then we standardize by the expected to get the cell chi-squareds. Check out chapter 19 going over this. Really good thing right there. But that's kind of how test questions are, where they ask you to just solve one thing. Okie dokie. Let's go back here and do the leaderboard. Optimistic. Blackbird still 5-point difference. Woohoo! I love it. Here we go. Which of the following must be met for the chi-square test of independence to be met, to be done? We've been practicing this. You should know it. It's the condition 3 and 4 for the chi-square test of independence. And great work, everybody, practicing the test right here. We got a lot of good output coming up. Start of Kahoot. So make sure you know your conditions and when to use them. Nearly normal. It's true. There is two. Skylar, great work. There are two. I think I didn't count 2 answers, so you get it right, whichever one you pick. You pick one of the 2. Nearly normal is for the what distribution. Nearly normal, say it with me, is for the what distribution. It's the third condition if you're doing the 1 or 2 sample what. Nearly normal is for the 1 or 2 sample what. So if you're analyzing the amount of money students spend at grocery stores, or the difference between like Florida and UT students on test scores, it'd be the nearly normal. Success failure is for 2 categories. Success failure is for proportions. I was already thinking about the conditions here. Success failure is for proportions, and counted data is one of the 2 for the chi-squared, where you have 2 categorical variables. Expected cell count we just covered, and it means all expected cell counts need to be greater than or equal to 5. So let's check out that leaderboard. Ooh, it is a battle right here. Oh no, where'd they go? It's still a battle though. Let's go on to the next question. The chi-squared test statistic is found how? And you can check out the formula sheet. If you do not know the answer right now, go to the formula sheet. Go to the formula sheet. We're talking about this value right here, which is the Pearson chi-squared test statistic. At 30 seconds, I'm going to go to the formula sheet and show you where it says the answer. This is the Pearson chi-squared test statistic. If you go across here, it's Pearson chi-squared test statistic. What is this value right here? It says prob greater than chi-squared. Does anyone know what that value is? Let's go show where this is out on the formula sheet. So what is that value I also highlighted? So look what it says right here. It says, oh wait, look at that. It says take those cell chi-squareds, and there's the answer right there. So there is the answer, the Pearson chi-squared test statistic. What is this value right here? Prob? Prob is what we call a what? Good work. Prob is the what of this test. Who knows and can answer in the chat? Prob is the what of this test. Prob is the what of this test. It's the sum of the cell chi-squareds was the answer. Prob is the p-value. So tell me, do you reject the null or fail to reject the null using the classic alpha? Now, alpha is a point at which you either reject or fail to reject the null. So researchers get to pick their alpha, but they usually pick 0.05 because it's kind of a standard. And so if we use the classic alpha of 0.05, p-value is much higher. And what's our saying? When the p-value is high, just let the null fly. Just let it be. That's what let it fly means. So we are not going to reject the null. Now, when the p-value is low, we reject the null. And what do we mean by low? Lower than alpha. So what if I play this game right here and do the following? My alpha level is now this. So take a look at where this p-value is at. So what can I do now? This is not good statistics. It's cheating. And we'll talk about why in a second by reviewing another concept very quickly. So I've changed my alpha level, which is the bar by which I can reject. And look, the p-value is lower than alpha. But who can tell me the huge theoretical problem that I've created by doing this? If I were to run all my tests this way, as a statistician, I'd create what problems, or think of an E word for myself. What problems am I going to be creating for myself right here? By raising my alpha level like this, I'm probably creating a lot of what? And Megan, you're right, but be specific. Your right answer right there. You got it. What? Which one? And the way to memorize it is 1, 2, A, B, and positive, negative. type 1 errors. Your alpha level literally is your type 1 error. So by increasing your alpha, you're going to get more false positives, i.e. reject the null when the null is true. And we have our famous saying, we'll practice this more later, got some really fun ones for it. But in a type 1, the null is true and we reject it. In a type 2, the null is false, that's an F, and we fail to reject it. How many Fs are there in our type 2 saying when we say in a type 2, the null is false and we fail to reject it? In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. And that's our mnemonic for remembering. And then try to think through some of these examples we do right here, because if you use that alpha level right there, you're probably going to make a lot of type 1 errors by rejecting the null when the null is true. So you're going to say, I have evidence, when you really don't. Okay, let's continue on right here with the next question. Purple Beetle, welcome to the lead. That's for you, Purple Beetle. Let's do this. Oh, and you would actually gain power, Carson. Carson, great job. Carson, if you increase your alpha, you gain power, but you increase your type 1 error rate by increasing alpha right there. So you would gain power. You would decrease your beta, though, because you've gained power. Power and beta are complements. Good questions, Carson. Next question. What is your decision regarding the null? We kind of covered this, so we showed where the p-value is at. More beta, less power. Yes, exactly. Beta and power are inversely related. Good answers, Joshua. And beta is governed by sample size, effect size, and alpha level. Question in the background. Notice the degrees of freedom here. How many levels do you think were there for X and Y? Because the degrees of freedom are this for the chi-squared, you can actually deduce what this came from. Think it only has 1 degree of freedom. So the X and the Y had how many? It was a 2 by 2. Because 2 by 2 turns into 1 by 1. The degrees of freedom are rows minus 1 times columns minus 1. So it had to have been a 2 by 2, because that's the only thing that turns into 1 times 1. So there we go. Nice work. Good work, Jake, and practice. So know your degrees of freedom for the t and the chi-squared. You know what? We'll review that right here, because I think everyone's going to say we failed to reject the null. Don't worry if you didn't put it, but the p-value is high. We failed to reject the null. We never say the word except here. Except is kind of a bad word. Don't worry if you put it, but you either reject the null or fail to reject the null. I do want to mention, when we say fail to reject the null, if my wife says, hey, did you go by the mall? And I say, I failed to go to the mall. What am I telling my wife? It's weird to say I failed to do it, but if my wife says, did you go to the mall? And I say, I failed to go to the mall. Translate that into normal person talk. I didn't go. So when you hear fail to reject the null, that means you didn't reject the null. So you either reject the null or you don't reject the null. You either go to the mall or you don't go to the mall. Does that make more sense? It's like a better way to say, like, if you hear me talk about it and I talk to people, I say, I reject the null or I don't reject the null. It's just an old way of saying, like, we failed to do this. Like, who talks that way? Statisticians. We have to teach you it. So if you hear this in another class, you have to know what they're saying. That's why we have to teach it. If I could convince the whole world to stop saying this, I would, but I can't. I can tell you what it means, though. Really briefly right here, degrees of freedom, because I don't think I go into huge detail on it in this review, but we use degrees of freedom 3 times, and it's actually in the formula sheet. I do have the formula sheet right here. So when you look at this, the 1 sample t is what? You can print off the formula sheet, and I do have some in the office here. The 1 sample t degrees of freedom are what? The 1 sample t degrees of freedom are what? N minus 1. The 1 sample t is n minus 1. The 2 sample t is what? Which is right here. It says it comes from the output. What's our mnemonic? Hence, it doesn't give you the formula. The 2 sample t is what? The 2 sample t is what? Too complicated. We don't have you do it. It's too complicated. 2 sample t degrees of freedom. So the 2 sample t degrees of freedom is this crazy formula over here. Crazy formula. Crazy formula. We're not going to have you solve that. And the chi-squared degrees of freedom are rows minus 1 times columns minus 1. So there is the chi-squared degrees of freedom. You just look at it and say, Brian, it's a 2 by 2. Drop. 1 times 1 is 1 degree of freedom. And I think I might have a question doing that. We'll find out. Let's go back to the leaderboard. Here we go. Leaderboard time. Purple Beetle holding on to that lead. Nice job. Knowing Lion. Optimistic Bird. Good to see you again. Here we go. How many degrees of freedom does this test have? Figure it out. Why'd I give you 90 seconds? Answer in the chat. There are 4 levels of classification at UT. There are 50 states. I know, and then there's also like, let's just use the 50 states. That's a nice number. So what would the degrees of freedom be if we look at the state someone is born in, the 50 states, and the 4 classes? Of course, there's graduate students and staff and faculty and everything. There's 4. So you can tell me the math in the chat and we can solve it. I think I got the number. Yeah, exactly. Adam got it. It's 49 times 3. Because you just say 50 minus 1 times 4 minus 1. There we go. So I'm giving harder questions right now. You get your 11 favorite restaurants, and you try to figure out if there's an association between class level and people liking those restaurants. So you have your 11 favorite restaurants and 4 class levels. So does anyone want to, what would the degrees of freedom be for that test? Your 11 favorite restaurants and the 4 class levels at UT. 30 degrees of freedom. And if people are wondering how we're getting this, I'll type it briefly in the chat. It's an 11 by 4, so that reduces to 10 times 3. You just drop one number and multiply. So for this one right here, Brian, this is a 2 by 2. It also says the answer on the screen. Delete one number, 1 times 1. I think people get this right. This is one of the ones that once you see it, you're like, and it's on the formula sheet. So this is a 2 by 2, reduces to 1 times 1, and there you go. And you can also do the L. I love that trick. Take the L and get the answer right. Don't take the literal L. You know, you don't want to miss the question. But if you go here, drawing the L is actually deleting 1 row, 1 column. So if you delete 1 row and 1 column, you are left with 1 block right there, and that is the 1 degree of freedom. So if you had a bigger thing like this right here, who wants to say how many degrees of freedom there are before I do this? How many degrees of freedom are there? So you can do the classic way. This is a 2 by 3. There's 2 degrees of freedom. Reduces to a 1 by 2. There's 2 degrees of freedom. Or you could do the delete method right here. Delete 1 row, delete 1 column, and the 2 cells. The most common mistake people make on this is they use the totals. People see the total values, and that's the most common mistake, where they see like these values here. Do not use these values here. If you see these values, these are totals, and they don't count towards the dimensions of the matrix. So the researcher doesn't pick the degrees of freedom, and it tells them the shape of the chi-squared distribution that they're using. So good answers right there. Good practice in the chat. And Carson, great work. Next, leaderboard. Purple Beetle still in the lead. Let's see who's going to win. What is the null for this test? You got it. You know it. It's the chi-squared test. Now, all you do is you go between the words and put what? Oh, man. I feel like they changed the music. It sounds faster. So the trick for the chi-squared test of independence, well, it's not really a trick. It's in the saying. So the chi-squared test of independence basically tells you the null. If you go between the words and write independent, you have the null. That this is independent of this. The alternative is simply going to be to write that they're not independent. Take a look right here at the test, though. What did we conclude? Using an alpha of 0.05, what did we conclude on this test? Remember, this is only for 2 categorical variables that you write the null this way. Other nulls are written differently. What do we conclude for this test right here? We reject the null that breaking a bone is independent of gender. So who was more likely to break a bone, guys or girls? Who was more likely to break a bone, guys or girls? Who was more likely to break a bone, guys or girls? Who do you think? It is men. You can see it up here. You can see the proportion of men who broke a bone is greater than the proportion of females who broke a bone. So do you think Brian's broken a bone? Yeah, I have actually. I don't go against the trend. Sometimes I do. I mean, there's a lot of guys who haven't broken a bone, but I decided to ride my bike, not with no handlebars, but I decided to ride my bike with no hands on the handlebars. And I flew off my bike and landed, and I did the karate thing where you fall and put your arm out to make sure you kind of take the impact, and my arm broke. I think it was my right arm. Maybe. Now let's do the next question. It was a long time ago. It was 30 years ago. I'm sad. What is the alternative for the test? What is the alternative for the test? It was a decade before anyone here was born. You're welcome, Lily. Great job. The review will be posted later. Check it out. So once again, we just talked about the null, and the alternative is just about as easy. To do the alternative, all you put is not. You have this little addition right here. So they are either, so breaking a bone is not independent of gender, and that would mean that they are associated. Sometimes I give the answer away. I won't for the next few. But the null is that they're independent, as in they have no relationship. The alternative would be that they're not independent, and we do have evidence for that right here. And we get the Pearson chi-squared test statistic, which is the sum of the cell chi-squareds. So you'd have to go through and calculate all those values, add them up, get the Pearson chi-squared, and then plot it on a chi-squared with 1 degree of freedom. And that would give you the p-value, different color. It'd give you the p-value over here, which is very, very tiny. It's off the curve. So it's definitely that the two are not independent, or you could say they're related. So it has nothing to do with the mean, because this is not a what. Has nothing to do with the mean, because this is not a what. When we do the mean, what test are we doing? So if you selected either of these, don't worry, but it's not a t-test. This is not a t-test. T-test deals with the mean, so that'd be a 2-sample or 1-sample t. Don't worry if you selected those, but those would be t-tests. And either of these is fine. You could say gender is not independent, or I like to say gender is associated. Like knowing someone's gender would give you some information about whether or not they've broken a bone. Like you might say men are more likely to break a bone. It doesn't mean if you're male you've broken a bone. It's just if you know someone's a guy, you're like, well, have you broken a bone? They're like, no. And you're like, oh, I thought so. You're a guy. And they'd be like, I would say the biggest thing associated with breaking a bone, actually, especially, well, guys cheerlead too. So I gave away what I was going to say. Cheerleading is crazy. Like in like a crazy way, like I'm not brave enough to cheerlead. I'm also not small enough to be a flyer. Anyone know what flyers are in cheerleading? I am not small enough. And shout outs to all, that must be the biggest fun, biggest thrill. Like people just take you and toss you in the air. Gymnastics, I like gymnastics. I can do pommel horse. I did cheer in high school. No, that's awesome, Zariah. I am not brave enough. I like gymnastics a lot. I'm brave enough to do that. I guess you don't get thrown in the air in gymnastics, but and also real quickly on this, not just the flyers, but if you have someone coming down from the air, you had to catch Zariah. That's it. Yeah, like catching a flyer. Oh my gosh, is that what it's called? The bases page right there. Yeah, it's my bases once dropped me. No grace. I was the back spot. Oh, okay. I'm gonna take a manager drink. Yeah, I think we can figure out other things associated with breaking bones, right? I'm not saying all cheerleaders break bones, but I could imagine that it's a very, I mean, that's an intense thing to do and totally a sport in my opinion, because you're willing to do that. I'm calling it a sport. We call it chess a sport, right? Hey, if chess is a sport, cheerleading's a sport. One time I was the only one to catch a girl. The other stepped away. It was Zariah. I wish I could give you some points, but shouts to Zariah right there. I bet that girl was so happy, and I really mean that because that probably made sure that they didn't get her. Funny thing is, I've broken multiple bones, but never anything related to gymnastics, even though, yeah, that's crazy, Megan, right there. You're like, gymnast, never from gymnastics. Well, there you go. There you go. Oh, no, Zariah. Rip my back, too. People have seen me around because I'm old. I got to stop making the joke. It gets less funny every year. Let's do the next question. Here we go. Purple Beetle in the lead. Having a little bit of fun here. Find the missing value in the output. Can you find it? So what are you trying to find? I'm giving hints to you. I'm giving hints. You're trying to find a what? You have 90 seconds to do what you might need to do, and I'm giving hints. You're trying to find a what? We'll start solving it around 60 seconds, but I'm trying to show you hints about the way this is laid out. The count is what you observe. It's how many people were born in Tennessee and were female. The expected, which is on the second row right here, and there's a missing value on, is how many you would expect due to random chance, given there's no association. The cell chi-squareds are the observed minus expected squared over expected. You can see they're down here and they're very small. They're very small because the observed and the expected don't have much of a difference. So let's start showing how to solve this. We are solving for an expected right here because it's the missing value when you look in line with it. So to solve for an expected, the math is row total times column total over grand total equals expected cell count. So the row total simply line up where the missing cell is. The column total simply line up where the missing cell is. The grand total simply go to the grand total right there. So the math is going to be 421 times 479 over 770. You could also kind of cheat, and the answer should be this one right here in blue, because it must add up to 421. So a double check right here. Did anyone use my double check method? That if you take this number right here, if you add up the values, trying to find a different color that's not going to be crazy. Well, sure. If you add up these values, they must add up to this. If you add across here, like these values would also add up. Did anyone do that solve method? We talked about it a little bit in class. It's not a real way to solve it, as in like, that's not the actual math, but it does work because the values across any of these, like if you go this way, this would add up to 291. If you go this way right here, you could also just add up all the values, and all the values in the table would have to add to 770, whether you do the expected or the observed, which is what you saw. How do people feel about this information? Is 258 supposed to be that is correct. We saw there were 258 females who were born in Tennessee. That is correct, Megan. And then we would expected by random chance for there to be this many. So we would have, that's even worse. We would have expected by random chance for there to be this many. That is the expected by random chance. Row total times column total for grand total. So good work right there. And excellent work. A lot of people got it. We've been covering that a lot in this review. Next question. Purple Beetle is still in the lead, breaking 10,000. Find the missing value. Now can you do it for a cell chi-squared? A cell chi-squared. So 2 seconds. I got to blank the screen because I have the answer on it. About to see the table again. A cell chi-squared. Okay, there you go. The cell chi-squared, as you can tell from this right here, cell chi-squared is going to be observed minus expected quantity squared over expected. And to do this, we can find the observed, which is the count here. That's what you saw. And we would need 128 there. And the expected is this. You can kind of quick solve it. You can cheat a little bit. It's about 4, but it would be 128. Here's a fun fact. It doesn't matter which way you subtract because you are going to square this quantity. And anything squared, positive or negative, turns out the same. And this should be the math. You got like 20 more seconds, right? There we go. Wow, called that. And so what I would do right here is I'd do 128 minus 131.895. Square that value, and then divide by 131.895. And there you go. There's the answer on the screen. So I think it's this one right here. Good work. What is the last opportunity to get points? So this is basically it. I'm not giving out any big points, and the points are so high that although Mubot is giving you tiny bits of points right here, the points from here won't really change anything. Does that make sense? I'm not hitting any of the points buttons. But so check your points now. Very good thing to do. Make sure to submit the graphic. Might try to do a stream or two more, but there won't be any points other than the tiny points. Like you might be able to get like 100 more points, but those won't change anything. The point levels are like way farther apart than 100 points because Mubot, by being active, I destroyed it during the probability lecture. I totally, because I was like, I'll give 1,000,000 points if this really rare thing happens. But then I wrote the code wrong and it happened twice. And I was like, whoa, that was super crazy. We're going to go on to the next question here soon right here. Oh yeah, it's down there at the bottom. Join in. Points affiliation. It totally was. And it was a crazy day. Oh yeah, let's show the equation again. Thank you, Megan, for asking. There's the equation. I'll disappear in the background so you can see it. You've got the count and the expected, and it solves to the cell chi-squared right there. And we'll be doing the next question here in just a second. There you go. There it is on the screen. You can always pause the screen too, and this is recorded. Yes, we will be doing that, Carson. Good question, Carson. We will be deleting those. And good to see you here in the chat. Here we go with the next one. Make Carson a mod. Standard mod. Carson, you're now mod. Next question. Let's do this. Here we go. Purple Beetle, Classy Newt, and Flying Panda in the lead. Next question. What are the degrees of freedom for the one sample t interval? And we have a mnemonic for remembering this. So use the information on the screen to find the degrees of freedom for the one sample t. What is the saying for the one sample t? The one sample t is what? Its degrees of freedom are what? The one sample t, degrees of freedom are what? N minus 1. Shouts to that guy giving out Red Bull today. N minus 1, N is 770, degrees of freedom are 769, N minus 1. And who can tell me theoretically what this distribution is going to look perfectly like? Like imagine, like watch this. What do you think the t-score for the 95% confidence interval would be for this? What do you think the t-score? So with 769 degrees of freedom, a t with 769 degrees of freedom, don't go... I bet it's going to be... Here's my guess, Joshua. I bet it's that. Oh, well, thank you right there, Jake. You're welcome. Hang out, and this will be recorded. And check out some of the other reviews. And let me know if you have questions. I appreciate that, Jake. Thank you. So what Joshua's done right there is because the degrees of freedom are so high, when you get to high degrees of freedom, the t basically is the what? When you get to very high degrees of freedom, the t is basically the what? At super duper 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 high degrees of freedom, and you're seeing this happen right now, the t is basically the one. We could go down to a few more decimals so you can watch it occurring. That classic 1.96 that we all know is approaching right here. So if I go to 769, I was off by 100th, Jake. I should have went 1.963. So I was, man... I don't know why they let me teach this class when I'm off by 100th on my estimate of a T, 769 degrees of freedom, 95% confidence. I mean, you could have just said 1.96 and been like, you're done right there. But the problem is the T and the Z are most different at what degrees of freedom? At what are degrees of freedom? The T and the Z, and you saw it earlier. No, Ava, I don't want to start that movement. The T and the Z are very different at very low degrees of freedom. I think this one's like 12 or something at 1 degree of freedom. I've seen it a lot. That's how I know that. Sorry, Owen, I'm trying, man. I'm trying. So at very low degrees of freedom, the T and the Z are very different. And then it goes back into the normal right here as you get to higher degrees of freedom. Who created the T distribution and where did he work? Famous story about the beer guy. Thank you, Owen. Famous story about the beer guy. He created this distribution and he worked where? He published in Biometrica. You don't got to know that. On the probable error of the mean in about 1905. He worked at Guinness. And his name was William Seeley Gossett. William Seeley Gossett. He feuded with Ronald Fisher, I think it was. But William Seeley Gossett. Mubot's putting some beers in the chat for all of us. Mubot, I don't know if everyone's 21. Chill out, Mubot. So with this in mind, that is the creator of the T distribution. He called it Student's T. Student was the name of the person publishing, like student published the work. And it was Student's T because student made the distribution. So it was their distribution, the T distribution. Maybe T for Gossett, I don't know. But he did it as a pseudonym. But William Seeley Gossett created it. We're going to Guinness beer. Might have to know that on the test. Let's do the next question with the leaderboard. Flying Panda, Flawless Enchilada, we love you. Classy Newt, Purple Beetle, and Swift Coral. Good to see you, Swift Coral. Next question. What is the missing p-value? And we covered this at the start. Let's see if you can get it. If you look at this, this is the what then test. This is the what then test. And that should clue you in on this one. This is the what then test. This is the what then test because P stands for probability. So this is the p-value of getting something, probability of getting something greater than T. And look, the T is over here at -3 almost. It's almost at -3. I know this is in context of the data, but it's about 3 standard errors below the mean. 3 standard errors below the mean. 3 standard errors. That's about what that says. That is about -3 standard errors. That difference is. What is the trick for the less than and greater than p-value? What is the trick for the less than and greater than p-value? Who knows the trick? What is the trick for them? They are compliments. Great job, Skylar and Megan also. They are compliments. Not complements with an I, which no one wrote. Complements with an E. Complements with an I is like great work. Complements with an E is 1 minus. So you know that these two right here, draw to the side. But when you have the greater than p value, this is going to be the area to the right of here. And right now we are trying to find the area to the left of there. That's the answer to that one right there. So there's the answer. It's simply going to be 1 minus. You could also, and notice I didn't do it that way. Who knows how I found it for this one? Because I did a different alternative solve because I used this one. So what did I do? And that's a more exact answer. If you round it, it turns into the answer that we would logically deduce. But what did I do? If you round it, it turns into this. Exactly, Megan. Because the other one is the does not equals, where you reflect this on the other side, giving you the does not equals. The does not equals p-value would be this one right here, which is if you take this and double it on the other side. So if this one, it would have to be, if you think about it, if you take point this and this on the other side, that's why even though we don't see the last decimal of this would logically be something around here. It'd be the 0.00205. Because then if you double that times 2, it equals this one right there. So that is that other way to find it right there. But more classically, we talk about the complement nature of these two p-values right here, where the less than and the greater than add up to 1. That's a very thing we try to mention. So good work on that one. Let's take a look. Here we go. This will be an easy one. I know what it is. It'll be easy if you just paid attention right there. So now we are missing the does not equals. This is greater than absolute value, as in if you had a t here, or the same absolute value on the other side. That's why it says probability greater than absolute value of t. So if you landed over here, well, a t of absolute value would be over here, and greater in terms of absolute value means more extreme. Like imagine -4. Is that greater in absolute value than this? Yeah, because absolute value of this is about 3, and 4, -4, are greater in absolute value. So those are things more extreme on the ends of the curve in terms of absolute value. So that's why we say probability of greater than your absolute value of your t, which also means anything like -4 has a greater absolute value than the absolute value of your t. And this one, complement means go to the other, it's complements means 1 minus. So notice how these two add up, they are complements. So the complement would be anything minus 1. And so the does not equals is always what times the smallest. Good work. So, great job, Zariah. The does not equals is always what times the smallest. So the first one up there is the does not equals. So this one, here, wait, let's do this. Go here and this. There we go. So this is the does not equals. This is the greater than. This is the less than. And if you're drawing them out, then you landed over here. You landed all the way down here at the bottom of the curve. So the greater than, exactly, everyone's saying 2 times the smallest. The smaller of the p-values is going to be this one right here. So when you do the absolute value of it, you land over here on this side of the curve. So all you do is reflect it. So these two are equal. So this is equal to this, and so you just double it. Does that make sense? It's just a reflection. Like, you know this is equal to that value. So you just reflect it on the other side of the curve, so it's 2 times it. So you just go and do that. So that is how you get it right there. Good work and good practice, everybody. So here we go. Next question. Leaderboard Flying Panda. Good work. What is the missing T ratio? A lot of people don't know how to get this, but can you find it? The T ratio is the T for the t-test. We are testing the difference in GPAs between males and females. So male minus female GPA. Now this will help with a later question if we've already solved this. What is this? What does this difference mean? Notice the difference is negative. Since the difference is negative, and I probably didn't help with this, especially in high school. Funny. Since the difference is negative, what does that mean? I'm going to go see some of my high school teachers. They're like, you do what now? Since the difference is negative, what does that mean? Well, the negative difference is associated with the second number. We would interpret this as, on average, females had a GPA that was 0.23 higher than males. On average, females had a GPA, because this is U male, or Y bar male, minus Y bar female. And we're trying to estimate the true difference between males and females. That would be the null that they're equal to 0, have no difference. Also, take a look here. Notice the standard error. The standard error is the formula square root s sub 1 over n sub 1 plus s sub 2 over n sub 2. Did anyone figure out how to get this? Because what do you simply do to find the t-statistic? Who figured it out and can tell us the math in the chat to find the t-statistic? So to find the t-statistic, we simply do what right here? And we basically have it written out. You simply do what to find the t? Does anyone know it? Well, isn't... You guessed, Megan. Good work on guessing it. I like that. And Carson has it right there because it's the difference divided by the standard. This is the difference. That's what the difference says right there. It's the average male minus the average female from our sample. And then we take right there, and great job, Margaret, also. We do the standard error. So difference divided by the standard error of the difference. This bottom, I've highlighted in yellow, is the standard error of the difference. And we need a little 2 on this, S sub 2. And that is literally equal to the t ratio. So y bar male minus y bar female over standard error of the difference is equal to t. So that has it. Simply divide the numbers, and people are putting in the chat. Thank you, chat, right there. So let's see. Did people get it? How many people got it? The answer is a few. Okay, good work. Good work. Next question. Let's do it. Here we go. Flying Pen in the lead. What is the missing value of the difference? So think about this. Well, you know that the difference has to be negative because the t ratio is negative. You can kind of cheat over here if you look at the graphic. But think about this. The t ratio is a ratio of the difference divided by the standard error. So this is telling you that the difference has to be this many times bigger. That's what the t is telling you. Also, let's look at the interval. Would you reject the null or not reject the null looking at the interval? In a 2-sample t-test, we're testing to see if the difference is equal to 0. So would you reject the null or not reject the null if we're trying to detect if there's a difference? Remember, the null is that the difference is 0. Would you reject the null or not reject the null? What do you think? So if you're testing if the difference is 0, reject the null or not reject the null. And you would if the p... You are correct. You can use the p-value to reject the null, but you can also use the interval. Because when you take a look at the interval, and great work, a lot of people got that one. It is from the previous thing, too. I do use a lot of pay attention things. I like it. And Carson's saying it right there. Great work. The value of 0 is not in the interval because the null hypothesis is that there is no difference. So if you have a null that the difference is equal to 0, so since the null is that the difference between males minus females is equal to 0, the hypothesized value of 0 is not in the interval. 0 is not contained in there. So it's not in that interval. So that means we reject 0 as a possible value. We can say we have evidence that the difference is not equal to 0. We reject the null that the difference between males and females is equal to 0. We have evidence that the true mean of male minus the true mean of female is not equal to 0 because, 1, you can say 0 is not contained in the interval. And what associated alpha level was used for this test using the interval? And I think we're back. It said OBS disconnected. Can someone give me a we're back in the chat? I think we are back because I see, yep, it does say reconnect. That's rare, but has happened before. What is the associated alpha level? Thank you so much. We're back. Love it. So what is the associated alpha level if the confidence interval is used? So when you do a test with a confidence interval, it naturally relates to the two-tailed test. And this one is nice because when making a 95% confidence interval, the outside of it right here is 5%. So it'd have 5% outside like the does not equals test. So exactly opposite of confidence. So it naturally relates to the two-tailed. I don't like doing the one-tailed version of it. You can if you cut it in half, but the does not equals test naturally relates. So a confidence interval can be used to test a value by looking to see if the intervals in the values in the interval. Since 0 is not contained in our 95% confidence interval, we would reject it on the two-tailed test, meaning the p-value has to be logically lower than 0.05, which is the associated alpha level. So this would be an alpha equal to 0.05 that the test would logically be ran at. You could change it and make it 98% and have a 2% alpha. And just to show that briefly right here, if the middle part of it was 98% covered, then, and that would say 98 over there, then you'd be running this at a 2% alpha level. And that means if 0 is not contained, you can reject it at the 2% alpha, which you would. It wouldn't contain it if we ran a 98% confidence interval. Next leaderboard, Flying Panda to lead, Swift Coral, and Classy Newt on fire. He's on fire! And not great impression. Was the null hypothesis for this test? What do you think? Now we have a quick trick for this. I don't know why I put 90 seconds on these, because you can get it like that. What is our quick trick that we always say? The null has the what? You can get it like this. Owen knows. He's on fire. It's like, he's on fire. It's a good reference. 90s video games. The null has the equal sign. The null has the equal sign. So you put the equal sign. I know, right? And what are you saying? What is another way to rewrite this null? Who can rewrite this null into the way I usually like to write it? I've written it both ways this semester. Rock knows. What is... It's a good game, right, Owen? Video, like, sports games used to be kind of crazier. I think MLB The Show might be fun. It always looks nice whenever I look at it. I got, like, Madden 25, but I haven't played it. I for, like, $5. What is another way to write the null? So this is one way. But if you think mathematically... Yeah, that's what I think. Well, and then make sure to have the muse on there. That is true. You want to have the muse because that's saying the true mean of male minus the true mean of female is equal to 0. Oh, the big head mode. Big head mode's in a lot of games like GoldenEye. You can get slappers. Yeah, it's classic. You unlock big head mode. I lost it. The other way, let's show the other way of doing it right here. Probably my favorite way. I was actually going to screenshot this screen. If you think mathematically, think if it's mu1 minus mu2, isn't it just the same thing to add like plus mu2 plus mu2? And what do you get if you add mu2 to both sides? Because you can do that with equality. You can add like, it's still equal if you add mu2 to both sides, but these mu2s cancel out. Does that make sense? Two mu2s. Make a mu2. And so mu1 equals mu2. So when you say they have no difference, you're saying the two means are equal. So if I say my brother and I are twins, my age minus his age is 0, I'm saying to you we have no difference in our age. We're not twins. But with this right here, mu1 minus mu2 equals 0 is saying they have no difference. To say they have no difference is to say they're equal. So I usually like to write it mu1 minus mu2, or I don't know, either way. Let's go to leaderboard. Flying Panda in the lead. Can you keep it? I hope so. I don't even know who they are. What is the alternative for the two-sided hypothesis test? Now, I do want to highlight right here the difference between a two-sided and two-sample. Who can explain in the chat what a two-sample means? What a two-sample t-test means, not a two-sided. What does a two-sample mean? There's a difference between two-sided and two-sample. You could have a two-sample, and Joshua's got it right there, the difference between two means. And that is for what we do in this class, because you could actually have a two-sample proportion test that is two-sided. What is the two samples? It is the difference between the means, but what does the two of the two sample mean? Well, it means you're taking a sample of one group and a sample of another group. And the two-sided relates to the alternative. So when we say two-sided, it goes to the shading on the two sides of the curve. Also sometimes called a two-tailed test. So you might hear it called a two-sided test or a two-tailed test. So it means you draw the two tails on the curve. One-tailed, one-sided. Two tails, two-sided. But two samples is different than two-sided. Does that make sense? Who follows me on this as we give a short mini lecture on that? We can do a two-sided for a two-sample, correct. So that would be if you were doing this one right here, because you have mean 1, mean 2. But what would be a one-sample, two-sided t-test? Can anyone give me the alternative for a one sample, two-sided t-test? Who can write in the chat right now the alternative for a one sample, and can you get to it before I can? The alternative for a one sample, two-sided t-test. Alternative for a one sample, two-sided t-test. The alternative for a one sample, so we have to write the correct, it has the does not equals because that's what the two-sided means. It's a t-test, so what are we testing? So the alternative for a one sample, two-sided t-test. So it's t, so we're testing what? Mu, mean. We're testing mu. And mu is equal to the hypothesized mean. There you go. How about, you ready? Let's do two more here. How about the alternative, and you can give two answers here, for the one sample, one-sided proportion test? One sample, one-sided proportion test. Nice job right there, Megan. One sample, one-sided proportion test. One sample, one-sided proportion test. There's two answers. One of the alternatives for the one sample, close shot. No, but proportion though. Proportion. Oh, I see it. And since it's proportion, it is P. And then we would have, there's two answers possible right here. It'd be P less than P naught, which is the hypothesized, like on the practice test, 0.75, but it wouldn't be mu. And here's the thing to remember. I'm going to write these above it for practice. If you pick P right here, then P naught is used here. If you pick mu, then mu naught is used right there. If you pick mu1 minus mu2, then we often test that the difference is equal to 0, which is technically delta naught. So with this right here, you can see if you were to say, let's test the mean, then automatically you get mu right here, and the null would just be that the mean is equal to some hypothesized mean. Now, the question's going to tell you something like, we hypothesize the mean is $20 for a meal at Cheddar's. I don't know. I want to eat at Cheddar's again for some reason. It's good food. Santa Fe spinach dip, Key West chicken and shrimp. Hope they still have those dishes. Check them out if they do. If they don't go to Cheddar's. Or go. Don't want to disparage anything. So with this in mind right here, you would simply plug in that value of $20 as the hypothesized value. So that makes mu naught equal to 20. You hypothesize the true mean is 20. Does that make sense? Who follows me that this would be the null and then the alternative be? What about a two-sample one-sided? So I'm going to ask a really hard one right here. Are you ready? Good job, Skylar, and this will be recorded. Thank you for being here. Here's a really hard question meant to be something that if you get it, you've learned more than this class. I would like you to do a two-sample proportion one-sided. Now, I'm trying to trick you. It's not really a trick, but we haven't covered it. Can you figure it out? A two-sample proportion one-sided alternative. So what would it logically be? Now, we've done the two-sample mean. So what do you think the two-sample proportion is? And then what does it mean that it's one-sided? So the one-sided always goes to the alternative. Very close, Zariah. Very close. I wish I was giving out points still. Very close, Zariah. Very, very close. And Megan has figured it out. Nice job. Great work as a team right here. So both Megans and Zariah all figuring it out. It would be the proportion 1 minus the proportion 2, the true proportions. Notice how we just carry the idea of P here. And then you would use the idea of 0. So you'd say is less than 0, because we're testing to see if there's a difference between the proportions. We don't do this one. We would do in our class the two-sample T. And by saying we're doing a T, that means we're dealing with means. So the two-sample T is this. Do you see how I just went from a two-sample proportions test, where you test the difference between two proportions, and you say the true difference between the proportions is 0? Not covered in this class, but you could think of what is a two-sample proportion one-sided test. Do people feel a little bit better about these ideas of like what is one-sided, what is two-sample? So the idea of two-sample goes to the idea of sample 1 and sample 2. So if you were to do a one sample, then you would just have a mean, and this would be a one sample T right here. So now that's a one sample T. Good job, Owens. Right there. That's what I want you to see. I want you to see how this like shows that this is a one sample. You're just testing a mean. You could also do a one sample proportion test right here. So this would be a one sample proportion test right here. And then you would change this to P for testing the proportion. And that's just a proportion being tested. So it's still one proportion being tested from one sample. We won't do the two sample proportion, correct. We used to do it years ago. And famously, a student said to me, do you even know how to do this? I got a question wrong. I could tell you where I was sitting. 3rd floor at this building. I got a question wrong. And they looked at me and they go, do you even know how to solve this? And like that gave me even more anxiety. It was like, I think it was my first semester teaching. Maybe I didn't know how to do it. I can't remember. Let's do it in the leaderboard. Oh man, don't be mean to your first year teachers. They're trying hard. They weren't mean. They were just critical. Flying Panda, Swift Coral, classy, nude, outstanding deer, and flawless. And here we go. Next question. Interpret the difference right here. I'll interpret it for you. It's kind of, oh no, we got it on the screen, but we did this earlier. So notice the difference is negative. So with the difference being negative, male minus female, what does it mean if it's negative? We'll just plug in some numbers. If it's 40 minus 30, which it's not because that'd be 10, well, that would lead to a positive difference and male would be higher. If it's 30 minus 40, that would lead to a negative difference. And this is what we observe in the sample. Y bar male minus Y bar female. So this difference is the difference observed in a sample. The standard error is the variation within the differences that we see. The confidence interval is going to be we are 95% confident that the true difference between males and females in their GPA is contained in the interval, females having as high as 0.015 higher to females having as high as 0.79 higher. The T ratio right there is going to be the difference over the standard error. The degrees of freedom are that too complicated formula, which will be solved for us or given to us. We should know theoretically it's too complicated. And the p-values are for the does not equals, the greater than, and the less than test. And the answer here is that females had this much higher of a GPA than males because the difference is negative. Which one you don't, I don't know how to get, I don't know how we know which is which. Which is which where? Which is which? Which one are you talking about, Soraya? I'll pause right here and then I'll explain. Oh, so the biggest thing is, do you see how there's the negative right there? So since the difference is negative, that would lead to us saying, because the way the math is done is it's Y bar male minus Y bar female. So if this equals a negative number, what sample mean was larger? If this equals a negative number, what sample mean? Oh, no worries, Grayson. Sorry about that. What sample mean was larger if this equals a negative number? Does that make sense right there? So if this was a positive number, it'd have to be something like 10 minus 8. It's not 10 minus 8, but if it led to a positive number, then it would have to be that the average of males was higher. Because this is what we are solving for right here to get the difference. The difference is literally this value right here of the difference is literally the sample mean of males minus the sample mean of females is equal to this. And since it's negative, that's associated with the second mean being larger. So this alone tells you that females had an average GPA higher than the average male. Good stuff. Next question. Flying Panda in the lead. Story time. The null is that it's a twig. You believe it's a twig. So you're walking through the woods and you make a type 1 error. So what's our saying about type 1 errors? In a type 1 error, I'm trying to let you see the answers, but in a type 1 error, the null is what? And a lot of people have trouble doing this, but I want to show you how to do this. Ready? In a type 1 error, the null is what? Here's our trick. In a type 1 error, it's a 1, the null is what? More, I like it. In a type 1 error, the null is what? True. Great job, Chloe, right there. So I want you to look at this and just tell me. So I want you to look at this. What does it mean if you, in a type 1 error, the null is true? So tell me about the world. Just tell me about the world. Don't go into detail about the type 1 error. I just want to know, when you say in a type 1 error, the null is true, what does that mean? In a type 1 error, the null is true. So just talk to me about the world. What does that mean? What are you telling me? The null is true. What does that mean? For this problem in this context, what does that mean? Don't go into great detail here. Just tell me about that. Yeah, that's a fact. Does that make sense, Ava? It is that. But what are you going to do? In a type 1 error, the null is true, but you what it? So the null is true. It is a twig. It's a little branch on the ground, but you reject it. The null is true, but you reject it. Who's ever made a type 1 error walking through the woods? You reject that and you think, snake. Snake. Dun, 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 dun. Dun, 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 dun. No one gets the reference. With this in mind right here, this is when you freak out and you're like, whoa. But it was just a branch on the ground. That's when you step on it and think in a type 2 error. I made a type 2 error. True story right here with Brian. True story with Brian. I was walking through and my friends in archaeology said, Brian, don't walk over that. And then you know what I heard? I heard shh. Because Brian made a what? In a type 2 error, the null is what? Tell me about the type 2 error. In a type 2 error, the null is what? I see Owen's had some encounters too. The null is false. So it's false. It is false that those are twigs. That is a fact of the world. They are not. They are snakes. It is false that they are twigs, but we failed to reject it, which means we retain it. So Brian was like, I'm just going to walk over this whole patch. It was a big patch of downed stuff. I mean, it wasn't literally snakes I was walking on. Those weren't all snakes. But I thought it was safe to walk on. I thought, no snakes here. And as soon as I stepped on it, oh, you heard those rattles. Oh, I made a type 2 error. Type 1 is when you freak out a thing that's not a snake, in this instance where the null is that it's not a snake. And then a type 2 is where you fail to reject the false null. So I was wrong. They were snakes, or at least there was snakes down there. But yeah, does that make sense? In a type 2 error, you fail to reject the false null. 2, fail to reject the false null. Type 1 error, the null is true, and we reject it. Our mnemonic for remembering it. Here is the other story for you. Let's check it out. Other story time, and here it is. The null is that a tree is healthy. You would think you need evidence a tree is sick to chop it down. So if the null is that the tree is healthy and you make a type 2 error, just tell me about the world. All I want to hear right now, don't go into the full thing, is talk to me about the world. In a type 2 error, what is going on in the world? I want what is going on in the world of a type 2 error. I don't want the full, I just want in the type 2 error, the null is false. So tell me what that means. In a type 2 error, the null is false. Oh, great job, Ming, right there. The null is false, exactly. So the tree is unhealthy. The null is false, but you fail to reject it. So if you don't reject the null, you keep the tree up, and then the picture shows you what happens is the tree falls on your house. I mean, that could be from a storm. I don't know. I just found a picture of a tree hitting a house. But the null is false, but you fail to reject it. It's false that your tree is healthy, but you don't reject it. Now, if you hire a company, why might you never find out that you made a type 1 error? Because tell me about someone who made a bunch of type 1 errors. So tell me about them. What did they do? What did they do? I'm trying to find a good picture to explain this. Oh, man. This person might have made a bunch of type 1 errors right here. Yeah, exactly right there. Megan's saying it. Like, how do you know if you go and cut down a bunch of trees, maybe sued for allegedly cutting down. They made a bunch of type 1 errors. They cut down a bunch of healthy trees right there. So that's my... So yeah, you don't want the tree to fall down. And that's kind of the cost, like which is worse. Well, if it's like a historic tree or a tree you really love, it might be worse to make a type 1 error. But the type 2 error, if the null is false and you fail to reject it, the tree hits your house. It just depends on how much you value the tree. We actually ran into a problem when we put this question on a test because we asked which is worse, and we were expecting people to say the type 2 error where you fail to cut down the tree that's actually sick. But then someone wrote in the comments like, if the tree is leaning towards my neighbor's property and I don't care them and I don't care if they sue, I'll let it happen. Like they clearly understood it, and then they wrote it in a way to be like, yeah, I'm going to keep that tree up. It means something to me. It was pretty interesting to read that response. But there you go. You leave the tree up and it's not healthy. That'd be the type 2 error where the null is false and you fail to reject it. Few more questions. Let's do it. Flying Panda in the lead. They raised their alpha. Yeah, you could. You could just never have a type 2 error and just destroy all your trees and you'd find all the sick trees, right? Want to find every tree that's going to hit your house? Chop them all down. Problem solved. Carson gets it right there. Type 1 errors alone, no type 2 errors. Infinite alpha glitch. This one, banks hate this one. What is it? It's a man. Banks hate, right? Homeowners love this one trick. Let's do it. Chop down all your trees. When doing a 2-sample t-test, the variables will be what? Ooh, this one caught people earlier today. And we gave a hint at the start of this one. So can you figure it out? The 2-sample t-test. Now, when you hear the t-test, this is where people get tricked. The t-test means you're analyzing what? The t-test means you're analyzing what? Because you know him, you love him. He's not too nice if you're doing drugs. Thank you, Ava. Analyzing means. Oh, that's all right, Grace. No worries. For practice. You're analyzing means, but the 2-sample t-test analyzes the what between two means. The 2-sample t-test analyzes the what between two means. Darn it, we don't have that up anymore. The 2-sample t-test analyzes the what between means. The difference. So imagine I have my class, Brian's class, and then Darren's class. Well, when people look at this, they unfortunately say, I see quantitative, quantitative. And a lot of people say quantitative, quantitative. But think, one variable would be average score on test, which would be quantitative. So that's where the means come from. The average score on the test is quantitative. But the other variable is categorical because it would be the class you're in. If we're analyzing class, Brian's class versus Darren's class leads to a categorical variable. So it's the difference between two categorical variable or the means of like Brian's class and Darren's class analyzed with things like box plots. And this is where we have the average or the score on the test. So score of the test, and we would analyze the difference. Does that make sense? If anyone put QQ, when do we do two quantitative variables like height and weight is analyzed using what statistical technique? I am drawing the graphic for it, but what is a statistical technique? And then we could mention two categorical, good question right there. Two quantitative variables is analyzed using what technique? So this is QQ over here. QQ is regression, scatter plots, correlation, and then two categorical variables. What is the name of the condition? And great questions, everyone. If you answer two categorical variables, when do we have two categorical variables? It's what test is two categorical variables. What graphic or test? And I don't know what's going on, but we're almost done and we'll make it through. This question does catch a bunch of people. OBS is being weird. More Mosaic everywhere. Great work and great practice and good to see everyone in the chat. So let's do our last two questions here. Here we go. Flying Panda in the lead. Next question. When working with statistical power, which of the following do we have the most control over? I think there's two right answers. What is the thing with statistical power? People don't want to answer because it's a competition for the lead. But what is something with statistical power that we'd want to alter? Power is the ability to correctly reject the false null. It's 1 minus beta. Beta is type 2 error. You only tangentially control beta. And so that's where do we have the most control over. I believe it's two right answers. There is one thing that we really don't control. I love using the zombie apocalypse example because if you're trying to, people already did it. Great job on the answers. Effect size is something that controls it. Let's draw our graphic because we only have a few more questions. I got a little energy, as BTS once said. So the things are the following. You have your sample size, which is n, and you don't really control effect size exactly. Effect size is the true difference between the null and the truth, and then your alpha level you do control. Why do you not mess around with alpha a lot of times? Why do statisticians usually keep alpha to 0.05? Just quick side question. Why do statisticians usually have alpha of 0.05? It's usually what we have because alpha directly controls your what? Most of the time, they keep it to 0.05 because it directly is your this. It is your type 1 error. Whatever your alpha is your type 1 error. Beta is your type 2 error. Just remember 1, 2, A, B. Are alpha and beta complements? R is alpha. Like if would beta be over here, would it be 0.95? Would it be 0.95? No, it's not how it works. It's because these three things right here control this. So what you'll notice is if you increase your alpha, it does decrease beta, but also your sample size increasing would decrease beta. Sample size is the absolute best way to increase power. Power being the ability to correctly reject the false null or to find results. Think about a zombie apocalypse. We'll do my favorite example from today. Who would have a better experience of finding zombies in the zombie apocalypse? And we would say they'd have a more powerful test, which is 1 minus beta. And power meaning ability to detect zombies in this example. Would it be the person who's been in the zombie apocalypse 1 day or 1 decade? Who would have a better ability to detect the zombie in a zombie apocalypse? Because think, we're altering the sample size. Who would have a better, more powerful ability to find zombies? The null being person is human, the alternative being zombies. So null is human, and alternative would be zombie. You need evidence they are a zombie. And it would definitely be the person, someone who blasts everyone also works. And Carson, so what is that person altering who's blasting everyone? That person right there is messing with their alpha. And if you set alpha equal to 0.0001, you're going to need a lot of evidence. Or you could set your alpha equal to 1.0 and you'll find all the zombies, but you'll make a lot of type 1 errors. So type 1 error in this instance means you're blasting humans. It means you're making false positives. You reject the null, but the null is true. So you say, I reject that you're human, but the null is true. You rejected that they're human, but they're actually still human. So type 1 errors are being made if you raise this. What is effect size in this instance? Effect size would be if somebody just has like 1 cut on their arm, little tiny cut, or effect size is someone comes walking through the door and they are just totally zombied out and they are drooling, foaming from the mouth, and just dripping blood everywhere, and they're just like, and they're eating an arm. They're like, yeah, you're like, okay, that is a big effect. Me after exam week, exactly. You don't even know what you're doing right there. Don't go that far. Don't go full zombie. Never, no, don't do that. So if you look right here, we've got a big effect. So when would you have a bigger ability to detect somebody as a zombie? When there is a bigger effect right there. Meal semester. We got to go back to here. We need summer to recover right there. So with this right here, when there's a bigger effect right here, that is where we see that it's easier to detect somebody is a zombie. With a bigger sample size right here, it'd be easier to detect somebody's a zombie. And so you can control, at least not to a certain extent, how long you're in the zombie apocalypse. And with this over here, you could alter your alpha level to increase the amount of times you reject the null, but then you make more type 1 errors and you end up taking out humans. Don't do that either. That's bad. Let's finish up the Kahoot right here. Next question. Here we go. Flying Panda, Swift Coral, Classy Nude, Optimistic Blackbird, and Flying Enchilada. Here we go. Calculate degrees of freedom. On this test, we have freshman, sophomore, junior, senior, and owning a bunny, which everyone should do. No yes. That bunny is not AI because I got that picture years ago. I think I've had that bunny picture for... This guy's such a smooth face. Anyone ever hear the term cute aggression? So when you see the cute animal, you're like, I want it. You just get so excited. Ricky Bobby. He actually looks like Ricky Bobby. It is such a beautiful picture. And I'll give you advice on... We'll explain how to solve this in a second. We're just kind of hanging out towards the end of this. Hanging out on the street. Same old thing we did last week. We did stats. You should do a picture of Ricky Bobby. I might have a picture of Ricky Bobby. I don't know. Ricky Bobby? I might show a picture of Morty. I don't know if I have a Ricky Bobby picture. I'll show you another Morty picture. Oh, it's one of my favorite Morty pictures. Makes me sad to see him, but he's such a good guy. That's a Morty. He's So big. It's such a big, fluffy, happy bunny. I'll show you one more Morty picture. We miss him a lot. That's him running around, I think. Let me try. 1 second. I'm going to see if I can. Okay, let's see. Does this play? Oh, there's a picture. It's him driving his car. This is when Morty got his driver's license. Morty would respond. You could snap and Morty would run right to you. I showed so many students. I might even find that video of it because I would show students. Like, I think I did a stream from the house one day and I was like, and Morty just ran right to me. But that's when he got his driver's license. It was so good. He was such a good little bunny. Do you get the time? Oh, we did. Yeah, we did get the topsoil down. So we did. Yeah, no. And Morty's having a nice time. Well, anyways, Miss Morty. I don't know. I still tell him like it's still here. One last. Okay, last Morty picture. Because I missed my bunny. And so here's my last Morty picture. He went into his little home, and I went down. He was just looking at me. I was like, "What are you doing?" And the rabbits love eating these homes. These are like cat scratcher homes. But the rabbits will just sit there and be like, and just eat the home apart. But he's such a good little guy. So yeah, Morty. Okay, one last one. Sleepy Morty. We had an area where he could go out to, and he would just pass out under the table, and that's when we just flop over and just pass out. So last Kahoot question. And then Jolly too. Jolly was our little guy. Morty was the bigger guy. Now we have Ricky, Bobby, and Celeste. Let's do the last question. Here we go. Leaderboard. Flying Panda, Swift Coral, Classy Newt. Love talking about my bunnies. And last question is, how could someone make this test more powerful? How do you make it more powerful? We covered this earlier. What is the best way to make this test more powerful? The best way to make the test more powerful. Woo! And congratulations. Great job, everybody. Kahoot was about an hour and 20 minutes, or hour 30 almost. And we had some fun. We enjoyed ourselves. And he beat SpongeBob to it. I love the shake and bake. Megan. I should get a picture of Ricky Bobby. Actually, I do have a picture of Ricky Bobby. We'll end with that. You do not control effect size. You do not control effect size. We actually have a very good picture of Ricky Bobby. Barely see him. Yeah. You only really control the sample size. Here, wait. Full screen Ricky Bobby right there. There's the Ricky Bobby in the picture. And there's the Celeste. That's Celeste right there. She has the cutest eyeshadow. She's the cutest. Yeah, Ricky Bobby and Celeste. Ricky Bobby's like a classic bunny. I think he was bought at Tractor Supply, and we're his third home. We take bunnies. Morty was a lab bunny. Jolly was a surrender. Celeste was a surrender, and Ricky Bobby was a surrender. Oh, they're all surrenders. And then there's Celeste right there. It's just so cute. Cute. Let's go back to Kahoot. Okay, let's see who won. Make sure to email me. Oh, wait.
Congratulations, Classy Newt. Tiny Brian here for the leaderboard. And Swift Coral in second place. And in first place, we have Flying Panda. Make sure to email Brian for those $20 Amazon gift cards. Tell him you won.
Great job. Why am I talking like Brian? It's all right. I'm glad they find homes for them. You got the W, Carson. Congratulations. I'm glad people find homes for animals. Like, I will admit, best case scenario, we want people to get animals that can give them forever homes. But if you have to rehome an animal, it's tough. I mean, like, it can happen. And the TN voice percentage, yeah, let's check TN voice. I need to send more reminders about that. So what is it? It's planning UTK. Let's check those TN voice percentages. I'll tell you this. I don't think I've sent enough reminders because I can be like, hey, do the TN voice. Was they due today? I sent out a reminder. When is it due by? Ends in 1 day. We're barely at 50%. I'll send a big reminder. So I think Mubot will say TN voice. So we need to send out a big reminder. It's easy to do. We usually get that 1 point. We sometimes get the 2, but the 90% is really hard to get. So do the TN voice, and I'll send out reminders to 207 because they can get the bonus too. So 207, if you haven't done the TN voice, do it. They're due tomorrow night, right? It takes 2 minutes, and it really matters to a lot of the lecturer people here, like myself. I am a lecturer, so what I do is teach. It's why I'm here doing a Kahoot and why we did a stream earlier today. So thank you for everyone who's done it. We are at 47%. The 479s are at like 60% and 40%. So let's get a higher percentage. Let's get everyone to do the TN voice. So you're saying I'm looking at all my section numbers. 340. I have 350 students. This semester I have about 360. I have about 440 students. As a student. With that, we're going to end off here. Bye for now, everyone. Ask any question if you got them. Email me, Discord. Say hey. Bye.